Yes, good. Hi, good afternoon. My name is Vries. I'm the founder of Continuum Security. We're a product security company, so we build two products to help you build secure software. The first product it's an open source tool called BDD Security. Basically takes Cucumber, OWASP, Zap, and allows you to write unit tests, or rather BDD tests, to automatically test your web applications in a developer-friendly format using BDD-style tests. And the second product we have is Erious Risk. It's an SDLC risk management tool that helps you do threat modeling and risk management across the SDLC. So myself, my background has been in AppSec. I've spent some of my career doing development work and some of my career doing consulting around application security. And of course, I've also delivered a lot of threat modeling training and threat modeling workshops. And that's what we're going to talk about today. So, can I see a show of hands who currently does threat modeling on a regular basis for their applications? Excellent. So that's a fair amount. Is the security team involved in every threat model? If you are doing threat modeling, hands up. Yes? Okay. And do you build more than 20 apps a year? Yeah? Who does more than 500 apps a year? One. Okay. If you're not doing threat modeling, why aren't you doing threat modeling? Who has A? It's too time consuming. Yeah? B, you don't have the skills to do it. Yeah? And I wasn't going to see, otherwise you wouldn't be here, right? So just to give you an idea on what everyone else is doing, the BSIM 6 study came out a few months ago, which is a study of 78 firms, which has some nice metrics about who's doing what in application security. So out of the firms that take part in the study, 85% of them do some type of security review of the security features that they're building in their applications. So it's a type of threat modeling, but of a limited set of features. 37% will do threat modeling on their applications or their high-risk applications. And 28% would have the security team as part of that threat modeling exercise. So you're in good company. And I think we're living really interesting times for software development, right? You know, we've got DevOps out there gaining a lot of ground. It's becoming extremely popular. Continuous everything. We want to do continuous security testing. And the message is clear that security can't be the thing that slows down development. Right? DevOps, Agile, these are not just whims that developers invented just because they felt like it. It's a real business imperative. We can deliver software quicker. We can deliver business value faster if we adopt these practices. And so naturally, the types of security activities that match with this fast flow model are not going to have that much resistance in the business. If you go to a product owner and say, we're going to do automated testing of your applications as part of your development pipeline, it's going to slow down your builds a minute or two. I'll say, great, fantastic. I get better security and it doesn't cost me much in terms of time. But if you try and sell threat modeling to that same product owner and say, well, we want to take 5 of your engineers for every product, put them in the room with a security architect and have them spend 5 hours creating a threat model of this application, well, no, that starts becoming a much tougher sell, and it starts to jam up this fast-moving process. And the reason is really because threat modeling is a thinking exercise, right? We haven't really automated threat modeling. We're still doing things manually. We have to think about threats. We have to analyze a system to be able to understand it firstly, and then secondly, to be able to identify the threats in the system. And if you've done threat modeling, maybe you've seen this, that as you spend more time doing your threat model, naturally you're going to find more things. And so your model starts approximating reality more and more as you spend more time and skills on the problem, as with most analysis activities. And the thing about this chart that I want to draw your attention to is that I found in my experience that it's a curve, right? It's not a linear relationship between those two axes, which means that when we start modeling, when we start looking at an architecture just in broad terms, we can usually identify threats quite quickly. So we usually see patterns emerging from the architecture. We can identify threats very quickly in the system. And as we spend more time in it, we start reaching a point of diminishing returns, right? We can spend a lot more time looking at the system, looking at every single interaction, and we're only going to find a few more threats there. So let's call this the easy stuff and the hard stuff, right? If we start doing threat modeling and we just do a basic architectural analysis and we don't look at every single interaction, we don't look at every single use case, we can get some of the way there, right? We can get a 50% threat model much faster than it takes us to do the second half of that 50%. But when we're doing threat modeling, if we're using something like Stride or Pasta or one of the threat modeling methodologies that kind of emphasize this thinking approach, we're doing thinking for the whole thing, right? So we're not differentiating between the stuff that's easy and the stuff that's hard. We're just doing one activity, which is think about threats and model threats all the way through. So my claim is that if we want to get a better ROI out of threat modeling, what we can do is try and speed up the easy bits, right? Let's try and get through the easy stuff as quickly as possible so that we have more time available to do the hard stuff. And you can even do it as an either or. You can say, for some of my applications that aren't so security critical, I'm only going to do the easy stuff. And I'm not even going to do the thinking parts of threat modeling, which we consider the hard and costly parts to do. Or you can do it an either or thing. So, well, we're going to do both things. We're going to first go through an easy type of fast, lightweight threat modeling, and then we're going to, in addition to that, do some of the thinking stuff and enumerate some of those hard-to-find threats. And the way I propose we can do this is by using bigger building blocks. So when we're doing threat modeling, we're looking at individual threats and individual countermeasures to figure out what the model is that we're trying to build. Instead of doing that, we can use larger components, which are either templates or patterns of threats. And we can attach these patterns to architectural patterns and say, I can build a model much faster using these larger components rather than finding individual threats for this type of application. And we're going to run into problems here, or we're going to run into, let's say, we're going to make a conscious compromise. Anytime you're building with components or with large building blocks, you're not going to be able to build as detailed or as custom a thing as you could by building it by hand, right? But this is going to be a conscious trade-off. We're going to say we're willing to do this because the speed gains are going to be much more important to us than the accuracy loss we get when we create our threat model. So the simplest way to start is with using broad templates or checklists. So a template across the entire architecture. And this will kind of work if you're always building the same type of application. If you're an ISV and you're always building, or you're focused on building mobile applications, or you're building web applications, you can create a generic template for that type of application, store it somewhere, and then have your developers go through that template, that checklist for every threat model. So they have a place to start off of, instead of starting off with a blank sheet and thinking about the problem and identifying the threats. They can start running with a template. And certainly if you're not doing any threat modeling, I think that's a great place to start, right? Because you can immediately start seeing value from using a template like that. And if you wanted to start with a template, I couldn't recommend anything better than the OWASP ASVS. So the OWASP ASVS, of course, is not a threat model template. It's a standard, it's a security standard, a list of controls, right? But like any standard, it has an inherent or an implicit threat model behind it. Okay, so for every control that we can see in ASVS, for example, that we should hash passwords, not store them in clear text in the database, if that's the countermeasure or the control, we can infer that the threat is if someone were to access the database, then they would get access to my user's credentials, and that's a bad thing. And if we knew that, we can also come up with alternative countermeasures. We can say, okay, so we have the threat, we have one countermeasure, we can come up with another countermeasure and say, let's enforce the use of using a third-party auth provider. And And to be useful, to have this as a reusable template, we can provide guidance to our developers and say, if you're going to use a third-party auth provider, use company X, and in fact, this is our preferred countermeasure. So rather do this countermeasure 2 instead of countermeasure 1. If you really have to store credentials, then do countermeasure 1. So this can become a template, something you don't need fancy tooling for. You can put it up on a wiki or in Excel even. And to get value from this, I think it's useful to have at least the threats and the controls. It's useful to have a risk rating as well. So this can inform your decision making. If your developers say, well, we're not going to implement this control, you can say, well, that means that you're going to be exposed to this threat. This threat we have decided is a high-risk threat that's going to cost us so much money if you don't implement this. That's why we need this particular control implemented. And you can also have vulnerabilities in there, which is useful for testing. So you can use the threat model to guide your security testing. I did security testing for about 15 years as a penetration tester and web app tester. Never, ever did a customer give us a threat model and say, this is what we want you to test. And I think that's really the logical way to go about testing, right? You need to test from a model. You need to test from something so that you know what's important and what you should have a look at. And having that vulnerabilities there will help you do that quickly. So that's quite a simple approach, and we're going to run into problems, of course, because the world does not look like one fixed template. Like we build lots of different types of applications. There's no way we're going to have one enormous template that's going to fit everything. Either the template's going to be too big, we're going to have too many things within our template, and the actual application that under analysis is not going to implement half of those things, and then we annoy our developers when they need to go through this checklist, which has got 80% irrelevant information in it. Or we have the inverse of that. Our template is not big enough, and developers have a much more complex system that they've built, and we don't really get much value out of using a template for the system. So we can do a simple optimization, which is don't model the whole architecture, just model individual components, right? Now developers have at least the ability to say, well, I'm using these 5 components, and I'm going to use these templates for these 5 components, and I can then create my threat model. So we'll be able to approach reality a bit better by breaking things down into components. You could have it uploaded to a central place. Developers download the component. They say, well, we're building an HTML web UI with one NoSQL database, an SQL database, and a SOAP web service. And they've got the templates there. They can download them and start using them. But we've kind of got the same problem in a different scale. Even if we look at in terms of components, not all web services are the same thing. Not all HTTP services are identical. Depending on what I'm doing with that web service, I'm going to have a different set of threats that apply to it. So we can further break it down by use cases. And we can create a template for the common use cases that we have within our product portfolio. So we can have things like an authentication use case for an HTTP service, and we can describe the threats and the countermeasures that we want or that we know about for an HTTP service. So from the user's perspective, this is quite usable. So if this is with developers that they want to go and use these templates, they could go and download them, figure out which use cases apply, and those use cases that don't apply to their app, they will just ignore them. But now we have a problem maintaining this list, because as the security team has to keep updating the threat models and the templates, we're going to have lots of repetition. So, for example, authentication from a web UI and the threats for authentication from a mobile device are going to overlap to some degree. And we're going to have lots of repetition between the threats and the countermeasures that we're recommending for all of these components. So that kind of template approach with individual use cases, I think it's useful if you're not doing much threat modeling yet and you want to start doing something. But if you're already doing threat modeling and you want to optimize the process, then I think we can do better than that. And we can look at even smaller components than a template and a use case, and we can look at risk patterns. So to have a look at how these risk patterns work, let's have a look at an example of doing a threat model for a simple login form on a web application. So we have 3 entities there. We have the web user interface, we have the use case that we're using, authenticate, and we have another component called the web service. So two components and a use case between the two components. And if we use a manual threat modeling technique, we can model this and we can say, well, let's say we've got 4 threats that come out of our model when we have a look at this system. So threat A, we have dictionary attack against username using common password. Threat B, we can bypass the login by replaying credentials. Threat C, we can post credentials to a spoofed server. And threat D, legitimate users cannot access the site because of a DOS condition. So let's say these are the 4 threats we find for this particular system. And to complete our threat model, we would include countermeasures for each of those threats. For developers to reuse this, we may have more than one countermeasure for the same threat, so that the development team can make a decision and say, well, we want to do countermeasure 1, not countermeasure 2 for this particular system. So we've got a bunch of countermeasures attached to threat A, threat B has a countermeasure, threat C, and threat D. So to really make these threats and countermeasures reusable, we need to decide how to attach them to our model. So in our model, we have a web UI component, we have an authenticate use case, and we have a web service on the other side. And now we can ask ourselves, for each of those threat countermeasure pieces that we had, do those threats and countermeasures apply to the component itself? In other words, regardless of what I'm doing with this component, does the threat just apply to the component as is? Or does the threat and countermeasure apply to the use case? So, for example, do the threats and countermeasures apply to the act of authentication, regardless of where I'm authenticating from or what I'm authenticating to? Does the threat pattern apply to the act of authentication? Or the third option, is it a combination of the two? So is it the fact that only when I'm authenticating to a known component or this type of component does the threat and countermeasure apply to the system? So the first one, I think it would be tempting to look at dictionary attacks against username and password and look at those countermeasures and say, well, that looks like something that applies to authentication as such, right? Anytime I'm authenticating, I could be exposed to that type of threat. But that wouldn't apply if we were building, say, a mobile client application. So if we're developing just a client-side app and we're authenticating to someone else's service, then that threat and countermeasures wouldn't apply to us, right? That only applies to a service or something that we're authenticating to. So we would say this is the third category. That threat and those countermeasures apply to a web service if I'm doing authentication to a web service. Threat B has the word browser in it, and the countermeasure says to set autocomplete on the login form. And those things will only apply to a web UI. And since it says the login is bypassed by replaying credentials, that tells me it's the authentication action that's part of the pattern here. So we would say that's part of the same case. It's if I'm using a web UI and I'm doing authentication, then that threat and countermeasure are going to apply to the system. And threat C, web service plus authentication, and threat D only applies to the web service, right? So threat D is interesting because it says legitimate users cannot access the service because of a DOS. Our countermeasure is enable upstream DOS protection. And that's inherent in the web service. It doesn't matter what I'm doing with that web service. If we have a web service, we're going to be exposed to this threat. So whether we're doing authentication or funds transfer or whatever, it doesn't matter. The fact of having a service means we're exposed to the potential for a DOS threat. So that was the first pass to figure out which threats, which countermeasures are attached to components, which of them are attached to use cases, or which are attached to the combination of the two. But now we can go a bit better and say, let's try and make this pattern as generic as possible. And while we're at it, let's try and see if we can come up with other patterns that are very similar to this one, but apply to a different set of components or use cases. So the very first one we said it is attached to a web service and authentication. But really, it's not authentication as such that's at issue here. It's only username and password authentication. If we were doing two-factor authentication, then this threat would not apply. If we were doing token-based authentication without a password, just a secret token, we wouldn't have a username, we wouldn't have a password. So we can't say that it applies to any type of authentication. We can say that that set of threats and countermeasures only applies if we're doing username password authentication. And it's against a service, and we don't care what service, right? Because that applies to Telnet, that applies to SSH. Same threats, same countermeasures, regardless of what the type of service is, but just the fact that it is a service is how we want to attach this threat and countermeasures. And the second example, we attached it to the web service and authentication. And we can say, yes, authentication is the right type of use case, because this is general authentication. Even if I were using 2FA here, we could still post those credentials to a spoofed server. So that threat and those countermeasures would apply even if we are using 2FA or even if we're using token-based authentication. Because our countermeasures say enable TLS on the server and set the HSTS header, it has to be an HTTP service, right? Well, it's HSTS that spoils the generalness of this pattern. So because we've said we want HSTS as one of the countermeasures here, we have to say this applies to an HTTP service. And threat B, login bypass by replaying the credentials stored in the browser. We said this applies to a web UI. So autocomplete in the browser has to be a web UI. And any type of authentication. So even if I were doing a token for some reason in the web UI, this pattern would apply to the system. And legitimate users cannot access the service because of DOS. Applies to any type of service. So it doesn't matter what we're doing with the service, we're going to have this risk pattern apply to it. Okay, so we've gone about and applied or thought about where our threats and countermeasures apply to our architecture, which use cases, which components. And now we can do something extra and say, well, let's take this known risk pattern and see, can we turn it, or can we find related patterns to this one? So we could say, well, we build web UIs, we also build mobile applications. So taking this very same threat, which is the login is bypassed, we can apply that same threat to the use case of a mobile device. So we can say login is bypassed by replaying credentials stored on the device. Our countermeasure is the same countermeasure, right? Countermeasure 4 on the top one says set autocomplete. Countermeasure 4 for our mobile device says do not store credentials on the device. It's the same countermeasure, it's just stated in different terms because they apply to different components. Which means that when our developers use our patterns, they will get information that's specific to them, that's useful to them. So they're not going to get general information, they're going to get more specific information. Right, I haven't lost too many of you there. Here we can see how they work in action. So let's take a client, the authenticate use case, and a type of server. We've got our 5 risk patterns there that we've identified. And we can now throw in different types of clients, different types of services, and see what threat model is generated by using these patterns. So firstly, if we're doing authentication against a web service is a generic service. So we get our threat D, our DOS risk is introduced there. The risk pattern authentication against an HTTP service is triggered because we are doing authentication. A web service is an HTTP service, therefore that pattern is going to be used. And we're doing user pass authentication against a type of service. A web service is a type of service, so we'll go and import that pattern as well. So we can generate our threat model based on these patterns. If we choose to just build a web UI, and we're doing authentication from web UI, we will trigger pattern number 1. If we're doing web UI on mobile, we'll get pattern number 1 and 2, and we'll have a merge of those two patterns. I'll come back to this a bit later. And if we're doing a REST API, we can say, well, the REST API was not something we considered in our original model. We modeled a web login form, right? But because of the way we've structured our patterns, we can say that a REST API is a type of HTTP service, and it's also a type of generic service. Therefore, we can at least start modeling something, right? So by stating things in general terms, we can model stuff that we hadn't thought of before, because we do have these generic threats that will apply to those components. SSH service, we never contemplated SSH service, but we are doing username pass authentication against a service, so we get threat A, and SSH service is a type of service, so we get threat D as well. And send mail. So even if we're not doing authentication, we're sending email, because SMTP is a service, at least we get threat D as well. So using these techniques, you can start building out a library of risk patterns. Some of those patterns are going to apply to the components themselves, and some of the patterns are going to apply to use cases, and others are going to apply to the combination of the component and the use case. And if you follow that idea of always looking for the most general form of the use case or the component, then you're naturally going to have a hierarchical relationship between your components and your use cases. So at the base for the components, the server-side components at least, we will have something like a generic service. And a data store would be a type of generic service, which means that we can inherit, if we choose to use a data store, we will inherit all of the threats that apply to generic service, and we'll add specific threats for a data store. And if we're doing an SQL DB, we'll inherit all of the threats that come from a data store, as well as all the threats from a generic service. And we can do the same thing for a use case like authentication there. We have authentication in general, which is divided into two types: single-factor authentication, two-factor authentication. And out of single-factor authentication, we would have username pass authentication and API token-based authentication. So looking a bit closer at this inheritance system here, we can actually copy a lot of what we're already doing in object-oriented design, right? So we inherit objects in OO design, and we can also overload methods in OO design. And we can do exactly the same thing with the risk patterns. So if we have a very general risk pattern, which is something like sensitive data storage on a client without specifying what type of client, could be a flash client, could be a mobile device, could be a web UI, whatever. We can state the threat in generic terms. So sensitive data is compromised if the client is compromised. Still don't know what the client is. And we can specify two countermeasures there. So do not store the credentials on the client, and if you really do have to, then at least encrypt the data that you're storing on the client. And from that, we can then inherit that threat pattern with use it in another threat pattern, which is more specific. So if we're building an iOS application, we can say we have exactly the same threat, but this time we're going to change the wording because we know we're on a mobile device. And we know that to encrypt something on an iOS device and do it securely, we may want to store it in the keychain, or we want to do something else with it. The point is that we can override whatever we've put in the generic pattern, put it into this more specific pattern, and we can now give developers specific advice about how to do something securely for iOS, rather than stating general things like encrypt stuff. It means that our generated threats and countermeasures would look something like this. So we would inherit everything from the first, and we would override any duplication of the countermeasures or threats with the more specific information that we have. Okay. So compared to the original plan of using a templated checklist of components, and developers can choose which components to apply, asking developers to go and choose which patterns apply to their architecture is going to defeat the whole purpose of this, because that's, we're going to waste their time. It's going to be very difficult for them to figure out which patterns apply to my system. So we've introduced we've solved one problem by using the risk patterns. We now have smaller building blocks that we can assemble into a pattern that more closely resembles reality. But the problem is how to do this assembly, right? Because they're now much smaller units. So there's actually two problems. The first problem is how do we demonstrate, or how do we code these inheritance hierarchies that we have between the components? How do we say that an HTTP service actually has to inherit from a generic service? And the second problem is how do we display this to the user being the developers who are going to use our threat modeling system. So I think there's a few ways you can do this. You can probably script it up. I think all of the ways that you choose to solve this is going to have to be something dynamic. You could possibly do it in Excel. I've seen people do amazing things in Excel, but personally I've never tried that. What we have tried, and what I think is a nice way to do it, is to use something like a rules engine, right? So a rules engine will express these inheritance hierarchies very clearly. You can do the same thing in Python. You can probably script it up. But I think using a rules engine is quite descriptive and is easy to read and understand. So if we didn't want to have a look at the inheritance relationships, using JBoss-D rules, this is what JBoss-D rules looks like. It's a simple if this then that type system. So we've got a set of conditions. If the conditions are true, then we will take some actions. And if you've worked with rules engines, you'll know that the rules don't really have an order of working. But anytime the state of the system changes, all the rules are fired again. So we start with rule number one. Say the user says, we're using a JSON service, and they say, choose JSON. We can insert a risk pattern into the knowledge session and say, we're using JSON. We're using a JSON service. The state of the system changes, and that will mean the second rule fires and says, okay, so we're using a JSON service. I know that a JSON service is an HTTP service, so we'll insert an HTTP service into the knowledge session. And we know that an HTTP service is a type of generic service, so we'll insert that into the session as well. So here we've established our inheritance hierarchy between the patterns. And that's quite a powerful system using the rules engine, and we can also use it to solve the first problem. How do we present all this to the user without exposing all of these risk patterns on the right-hand side for them to choose? So we can abstract that away from them and say, well, the rules engine can take care of all of that. It can make the decisions about which patterns need to apply when. All I need to ask the user is stuff that the user is familiar with, right? So tell me about your architecture. Tell me what component you're building. So they just say they're building a web service and they're doing username and password authentication. We can feed that into the rules engine as long as we have rules that say, right, so we know how to deal with those two types of situations. And by answering two questions, we've got 6 risk patterns that were selected by the rules engine that apply to this particular type of architecture. And these are the rules that could do something like that. So user says, we want a web service. We say, okay, we're going to insert the HTTP service risk pattern. We're doing username and password auth. Okay, we'll insert single-factor authentication risk pattern. And then the third rule does the magic, which says if I'm doing authentication and I'm using an HTTP service, then I can draw 3 more conclusions. I can say I'm transporting sensitive data because I'm transporting the authentication credentials across a network. I'm dealing with a stateful session because I'm authenticating, so there needs to be some kind of state there. And we can include some specific risks that apply to the act of doing single-factor authentication over an HTTP service. Right. So these rules can hide the complexity of choosing which risk patterns to apply when, based purely on an architectural questionnaire. So you just ask the user, we're building this type of architecture, rules engine decides which patterns to import based on that architecture. Okay, so we can have quite a powerful system to be able to choose which risk patterns apply when using these, using a rules engine and using the risk pattern concept. But we've taken some shortcuts to get here. So the first shortcut is that we don't have any data flows. We don't have any trust boundaries in our model. We just say, we're using these components, we're using these use cases, and we never say where they are in our architecture. So we're not saying whether they're inside a private trusted network or they're out on the internet. So we're going to get more threats than what actually applies to the system, right? And of course, if the user doesn't select the right type of components, the right type of use cases, we're going to generate incorrect information. We're going to generate a threat model that doesn't actually apply to the system. And I think the biggest problem, well, the biggest challenge is that any type of checklist, anytime you introduce a checklist, it's going to short-circuit thinking about the problem. But this is a conscious decision we made at the start, right? We said, it's okay to short-circuit some thinking for easy tasks. We gain speed, we gain scalability by allowing this to apply to, by allowing developers themselves to generate these threat models. And we can always decide that we do want to do the thinking as well, but we can do it after the fact. So we can start off with a checklist, and then afterwards we can say, well, we do want to do more detailed threat modeling, and we can build off what we have already. So we're just getting started with a checklist. It's not necessarily replacing standard stride-based threat modeling or pasta-based threat modeling with a checklist. It can be a complementary aspect to it. The advantage are speed and scale. So not only is it quicker for us to do individual threat models, but we can do many more of them because we don't need security teams to be involved in the threat modeling. We can hand this stuff off to developers and say, self-service, secure design. Here you have your templates or you have your risk patterns, use the system, and you can start building your own threat models, and you don't have to involve the security team. The other advantage, I think, particularly of the rules engine approach, is what you're effectively doing is taking the expertise that's built into your security team, so the guys who know how to build threat models and which threat models apply to which types of architecture. You're extracting that from their heads, and you're documenting it in patterns and in rules, which is then reusable within the organization. So you're not losing that information if your rockstar security engineer leaves the company. You have that information in a central place or a persistent store, which also means you have improved consistency, which is one of the nice things that I really like about checklists. Because you can have a consistent approach to your threat modeling. If you can do the same model for the same application, you're going to get exactly the same results. If the security analyst looking at the code is having a bad day and they're doing manual threat modeling, you're going to have, it's possible to have different results or different threat models generated for the system. Questions? Yes. Oh, sorry. We need to wait for a microphone. Yeah. Thank you.
All right, so I'm going to kind of put you on the spot. So if your answer on this is I don't quite know, then that's cool. But I'm thinking of combining this in my head just now. I'm thinking of combining this with the security champions paradigm. The idea where you're for those in the room that aren't familiar with it, the idea that you spin up, for instance, like senior level developers within different development teams or what have you around the organization as people that can champion security within their own teams who aren't actually a part of an application security program. So my thinking here is, okay, we have let's say a rules engine based approach like what you've got going, and then that gets most of the hard work done, and then maybe if there's already a security champion within that given team that is familiar with the architecture, working one-on-one with that person would be a good way to get more insight with say the trust boundaries, data flows, things like that. Do you think off the top of your head, this is very much putting you on the spot, that would probably be a good compromise to get even further than just a rules engine based approach, if you already have a good security champions program in place?
Yeah, so the main constraint, I think, is the number of security champions you have within your organization. So those 78 firms who took part in the BSIM, they have 1.5 people in the security team versus for every 100 developers that they have developing code, right? And those are companies that are relatively mature in their processes. So I think if you have that ratio, or you doing better than that ratio, and you have security champions in your organization, then I think that's definitely a way to go. Because the thing I like about security champions is that you're sharing knowledge with the developers, right? And it doesn't have to be an either-or type of approach. So you can use the rules engine, can use the patterns, get them started, and then, as you say, get the security champions involved and say, well, let's go further. Let's have a look at the real business risks for each application. So the other thing about using patterns is you're only going to create patterns for the stuff that's repeating in your architecture. If you're a bank, you're going to create a pattern for funds transfer, right? Because you see that a lot. A lot of applications are going to use that use case, so you want to have a pattern for it. But if you build an application that's slightly different and has some other use case, that's not going to fit into this pattern-based approach. And that's where you'll have to use something like security champions or the security team to handle those types of threats. Thanks.
So my question is, this appears like it appears to be a significant investment to go through that entire process and creating those rules.
Yes.
Isn't there anything in the industry that just provides a bunch of libraries that you can already use that way, as opposed to, because I'm guessing an application is an application, a web service is a web service, regardless of the group or the company that's building it?
To some degree. So that's why I kind of recommend starting with the OWASP ASVS, because ASVS has that approach. ASVS says, well, we're going to model web applications and mobile applications, and these are the standards, or these are the controls that are going to apply to those types of things. So I think if you wanted to start off, ASVS is the thing to start with. On the other side of the spectrum, you have KPEC, so the Common Attack Patterns and something. So they're just it's an enormous list of attack patterns. So they're not really grouped for web or for mobile. It's just an enormous list that you can start off with. So I certainly would start off with ASVS, but you can look at KPEC as well as an alternative. Yeah.
Hi, Stephen, it's Andrew. Obviously, I'm a huge fan of the ASVS, so thank you. My real question is, the number one issue I find with doing threat modeling is that it's abandonware as soon as I finished it.
Yeah.
How have you approached development teams to keep it up to date after you've finished?
Yeah, so I think that's more kind of a management issue of threats, and I think that the thing you want to do is not have threat modeling as some special security activity that's only owned by the security team and is mandated once for every sprint, and the security team then takes the results and goes away with it. I think the key to it is if you can take the results from your threat model, which are your countermeasures, and those countermeasures then go into Jira or they go into your ticketing system, and they become part of the development process. And once it starts becoming part of the process, then it's going to be, well, developers are going to pay attention to it, right? Because it's part of normal development. Security requirements is just another requirement that I have as part of the system.
Hi, Diana with U.S. Courts. I don't work for this company, but we're currently evaluating a product from Security Compass called SD Elements.
Mm-hmm.
I imagine you're probably aware of it.
Yes.
Great. Could you speak to how it's relevant to this, or isn't relevant?
Yeah, so I think SD Elements uses a similar type of system, but I don't know their system, so I couldn't really comment on how it works, other than it has a questionnaire, and what comes out on the other end is a set of requirements. How it's doing that in between, I don't really know. Yes.
Okay, I'm from Ford Motor Company, and I'm trying to start a threat modeling discipline and spreading it out there, and I'll use security disciples throughout the organization. Even then, I don't really want to leave it in their hands entirely, because I want to make sure those security requirements that become controls actually happen. But I do see this as, for me, very complementary with doing the typical Stride, and I use the Microsoft tool.
Yeah.
So I see the initial practice of doing the diagram in Stride very helpful, because half of it is educational, frankly. Most of the people I'm working with, architects that don't have a good security understanding, don't understand threats, don't understand risks. So I find that value. I don't want to lose that. The diagram itself provides a focal point. I actually find out people, another quarter of what comes out of it is, they don't even understand their own app and how things work together. It's like, oh, I thought that service was outside. No, it's inside, that sort of stuff, right? But when I get to the threat stack, that's where I lose participation and value because, oh, well, is this one really applicable? Is it not? So it becomes very laborious. So I think if I make this after doing the diagram, I can manually, and my time is much cheaper than 20 people in a group's time, right? So the person who said it's a lot of investment, well, yeah, my time investment is versus hundreds of developers is cheap, right?
Right.
So I envision using this to filter through the threats. So then when I actually do a walkthrough, it's only threats that are relevant, and now it can be in the framework of what they'll understand. And then we're all working from the same picture. So I appreciate this. It resonates.
Yeah. And I think that there's repeating what you said about the diagramming part of threat modeling as something that someone said on Twitter, which is the first part of threat modeling, you're not even talking about threats. It's just agreeing on what the architecture is. And just that act of having developers sit together and discuss what is my architecture, what talks to what, just that thing is educational enough. You're already getting threats coming out of that just because there were assumptions made here or assumptions made there and nobody quite understands how the system hangs together. Yeah.
Any other questions?
We rely on using the ASVS a lot, but in the end, always getting the answer back says, hey, we're in the internal network. So you don't have to worry about all those threats.
Yeah.
And another issue we experience a lot is cloud adoption of ASVS.
Sorry, what is ASVS?
The cloud.
Yeah.
Lots of systems are going to cloud. So, should we adapt it a little bit tighter or more loosely adapt? It seems like OWASP ASVS doesn't address that.
Yeah. So I would create and use the ASVS as the base if you have success with that, and modify it for the cloud. Have 3 ASVSs: your ASVS cloud, your ASVS internal network, and your ASVS everything else. And you can add your own threats and your own countermeasures that apply to cloud. You can consult other standards for that. So you'd effectively have 3 templates that you can draw from. Say, well, we're building an internal app. Okay, so these are the threats we want to have a look at. We don't care about denial of service or what else. So yeah, I think you could easily split up ASVS. Although I think it's quite a well-adopted standard, ASVS. It's also encouraged from the ASVS team themselves is that, use it as a starting point. Start off with ASVS, but change it. If some things don't apply to your network, cut them out or add things that you are concerned about. Okay.
I really like the use of the patterns, but one of the concerns I have is maintenance. When you develop new attributes to the pattern, how do you roll those new attributes and patterns out to all the models?
Yes. So, right. So you would have to use, you'd have to do it in software, right? So you'd have to build some kind of a system where if you're going to use a rules engine, you're going to use the patterns described, store the patterns in the database, you'll have to have like an update module that says, when I go and update this pattern, I now want it to apply to all of the models that I previously generated over the last year or 5 years or whatever, and they should all go and get this new threat that has been applied to the pattern. I don't know any other way to do it except to build it in software or scripting or something like that. Yeah. You could potentially also have like a feedback loop. So once the threat model is generated, and the users can then look at this model and say, this threat doesn't apply to me, or this is okay. And they can also add threats. And when they add a threat, have some way to say, well, you're adding this threat to this model. Do you also want to feed it back into the library? And which risk pattern do you want to feed it back into? So yeah, it starts becoming complex, but it's not insolvable. Yeah. Any others? Super. Thank you very much.